Okay, so welcome back. Don't forget to ask your question in the chat and then we'll answer it at the end. So the floor is yours, Erik.
Thank you very much. My name is Erik Rasmussen, and I'm with Stena Recycling, as shown on the slide. And I'm also the product manager of the Life HaloSep project, which is described in the bottom. It's a cooperation between Vestforbrænding, which is the largest waste-to-energy plant in Denmark. We have received some funding by the EU under the LIFE program. And the final company I'm going to speak about is HaloSep AB, which is a Swedish company founded earlier this year by Stena. And HaloSep AB will be responsible for the marketing and sales of HaloSep plants all over the world. So let's see what the HaloSep process can do. Next slide, please. Michael, can you shift? Hello. Oh. Michael.
But it is not shifting, of course. I'll try. It's not shifting. Okay, so I guess I have to stop sharing and try again. Sorry. No, it's not doing it. So I just close and start again. Sorry about that. There seems to be something with the presentation. Do you have a lot of animation or something special? No.
No, not really.
It's not huge either, so.
No.
Okay, let's try again. Okay. Wait, I try something else. I'm just trying to check if with local copy. Can you see the slides now?
Yes, I can see it, but it's not in the...
I'm trying the full mode again. Yes, okay.
Here we go. Okay.
Sorry.
I'll try to catch up. I'm sorry for this inconvenience.
Sorry.
The agenda of my presentation is first to tell you about a little bit about the process, a few slides, then go into detail about the fractions coming out of the HaloSep process. And finally, I will go through the status of the demonstration project that we are conducting at Vestforbrænding Waste to Energy Plant. Next slide, please. Michael.
It's freezing again.
I don't know.
It moved. It's the first time, of course, I experienced that.
Otherwise, Michael, just keep it in editing mode.
Yes.
Yeah.
I will have to do that, but I have to go to the editing mode.
Just open the presentation, and then you will be in the editing mode. So the first view.
Yeah, it's just that I cannot. Okay, now it's moving again.
Great. Okay. I'll take it from here again. This slide shows you how the HaloSep process is integrated into an existing waste-to-energy plant. We have the green box, which is the HaloSep process. We combine it with the scrubber liquid from the HCl scrubber, the fly ash silos, and then we need a water source, and at Vestforbrænding, this will be flue gas condensate. The products coming out of the process is, in the gray box, treated material larger than 1 millimeter, which is going back to the ovens. And then we have the treated fly ash in the blue box on the left top. And the treated material can either go to landfill disposal, or it can be used as a construction material, depending on classification of the material. In the next box, you see the third product coming out of the process, the metal product, which is going to zinc recycling. The last box is the salt product, which we plan to go for salt recycling, at least a part of the year. And you can see that the salt product can also, on the right, go to the existing wastewater treatment plant. Yeah, next slide, please. A little bit into the green box. What is the actual flow sheet? This is a simplified flow sheet, but it tells you a little bit what's going on. On your left, you see the fly ash, the scrubber liquid, and the water source. It's going into a reaction tanks, number one. From the reaction tanks, the material is sieved, and we take out oversized treated material, the gray box on the upper right. Going from the sieve into a reaction tank number two, and from the reaction tank number two into a separation stage one, where we separate the treated material, the treated fly ash, from salts and metals in solution. The material then goes into a washing stage one, the treated fly ash go into a washing stage one, where we allow it to be washed with water. And from that stage, it goes into a separation stage two for the final dewatering of the treated fly ash, going to the right in the bottom. If we go back to the separation one, we see the metals and salts in solution going into a precipitation stage. From the precipitation stage, we go into a sedimentation stage, and further into a separation stage number three, where we separate out the salt product, and the metal product, now in a form of filter cakes, is going into a washing stage two, where we add water and in order to remove chlorides from the metal products. We then go into a separation stage four before we go into a drying stage, and then we have the last product, the metal product, going out on the right. Next slide, please. A little bit about the different distribution of fractions, depending on if we treat fly ash from wet flue gas treatment or semi-dry flue gas, semi-dry fly ash, fly ash coming from semi-dry flue gas treatment. The major difference is that when we see the amount of treated fly ash, it's about 60% coming out of fly ash from wet flue gas treatment, where it's much less, about 40% coming out of semi-dry flue gas cleaning. On the other hand, the salt product is increased from 25 to 30% and up to about 45 to 50%. Metal products is about the same, and the same goes for oversized material. And another difference is that the amount of water generated in the process is increased when you treat semi-dry material. Next slide, please. So let's go through the fractions. Next slide, please. The material, the fraction number one was the oversized material. It's a very small fraction, less than 1% of the incoming fly ash. However, it has a very high TOC content. You can actually see the black stuff on the picture. So this material will be returned to the incinerator ovens. Next slide, please. If we look at the treated fly ash, the amount of that will be about 60%. And speaking about technical challenges through the development of this process, we had in 2015, we had about 0.5% of lead in the treated material. And the hazardous waste limit values, according to the CLP regulation, was 0.5%, so we were close to the limit. And then the EU changed this limit value to 0.3% in 2016. So we had to go back and do some pilot testing in order to meet this demand. So in 2017, we have routinely about 0.2 to 0.26% lead in the treated material. With respect to organic substances, there really is not any problem. Basically, all the organic substances show that the material can be characterized as inert waste. So I won't go into details about that. So today we have a situation where no single substances causes inherent hazardous waste properties of the treated fly ash from waste providing. Next slide, please. If we do a classification of the material, the treated fly ash, then we have a number of irrelevant or not relevant hazardous properties shown here. We can classify the material as non-hazardous waste with respect to the 7 other hazardous waste properties. And the only one to consider is the ecotoxic HP14 and the NH410. And if you do a worst class classification of the treated material based on maximum leaching values for lead, copper, and zinc at a liquid solid ratio 10, then the material will come out as non-hazardous waste. And further, we also expect non-hazardous waste classification when biotest will be used for HP14. So non-hazardous waste classification of the treated fly ash makes it possible to be used for other applications. And applications such as use as a construction material will be evaluated and tested in the operational period of the life HaloSep project. What this means is that we have to do classification of the treated fly ash during the 4 operational test periods of the life HaloSep project starting on October 12th next week. In the meantime, we have to have a temporary disposal of the treated fly ash. And of course, leaching test will determine whether the treated fly ash should go to a disposal site, class inert waste, mineral waste, or hazardous waste, according to the EU legislation. Next, please. Here I show the column leaching data for the treated fly ash. And in order to make a long story short, we now comply with the leaching values for a disposal site class non-hazardous waste. And this is shown by the color coding, where if the material has a green color, you can place it on an inert waste disposal site. If it's yellow, you have to go to a non-hazardous waste or mineral waste disposal site. And if it's gray, you had to dispose it on a hazardous waste disposal site. A little more about challenges during the development of the process. During the pilot testing, we experienced that antimony leaching was occasionally above 0.7 milligrams per kilo, which meant that we had to go to a hazardous waste disposal site. But in 2018, we found a technical solution for the antimony leaching, and in order to fulfill the mineral waste leaching limit for antimony. Yes, next slide, please. The third product, or the salt product, is about 25 to up to 50% of the incoming fly ash. And in the table on the right, I've shown the max limit values for trace metals in de-icing agents from TC337. The right column shows the trace metal in the salt product from Vestforbrænding. And what you can conclude from these figures is that the salt quality is okay with respect to using this material for de-icing agent. So The use of the salt product for road de-icing will be validated in the operational period of the live HaloSep demonstration project. And the next, please. The metal product is about 3% of the incoming fly ash. The zinc content is 37 to 45%, or corresponding to about up to 68% zinc hydroxide. It has a lead content about up to 3% and a cadmium content up to 1%, and then there are other inerts. The metal product will be sent out to zinc recycling outside the plant for zinc recovery. And the optimization of the zinc yield and concentration will be further developed in the operational period of the live HaloSep demonstration project. Next, please. Let's go to the demonstration project and the status here. Yeah, the plant status is that everything is in place, mounted and ready for hot tests, shown here in the bottom bullet point. We plan to do the hot test with fly ash and scrubber liquids starting on October the 12th. Next, please. A few pictures showing the building of the construction of the plant, starting with mounting of mini piles for reinforcing the floor for taking the loads. And the middle slide showing the castings of foundations, machine, pumps, etc., about 101 of them. And on the right, the steel structure beginning to emerge. Next slide, please. We see on the left, we have the ash receiver coming from the ash silos. We have in the middle, we have the HaloSep supply tanks, which is 2 scrubber liquids coming from the 2 different lines that are existing at Vestforbrænding. We have the return water or the process water tank, and we have the flue gas condensate tank. On the right, you have the heart of the process, the HaloSep reaction tanks. Next slide, please. The separation of different streams are done with classical chemical equipment. We have a separation stage 1, which is shown on the upper left. It's a band filter. We have in the middle a filter press for the final dewatering of the washed treated fly ash. On the bottom left, we have the separation 3 for the separation of salt from precipitated metals. We have the upper right is the separation of washed metal product, and the filter cake from this is going into the dryer shown on the right bottom picture. Next, please. Here a view of the middle deck showing the precipitation tanks, the sedimentation tanks. In the back of the orange tanks, you have the supply tanks. And on the right, you have the spillage collection tank, metal washing tank, and one of the reaction tanks. In the middle, you just see the spillage pit surrounding the supply tanks. And on the left, the right, you have the slurry buffer tank, the filter cake washing tank, and the sedimentation tank. Next, please. Okay, finally, we show here a screen on the right, a screen picture of the HaloSep plant in the main control room at Vestforbrænding, where you can control the process. Next slide, please. Next. Okay, the expected results is that we will build an approximately 13 to 14,000 tons per year HaloSep plant in an existing flue gas cleaning building at VF, that we have done that. We have integrated the HaloSep plant with the existing flue gas cleaning plant and the existing wastewater treatment plant. And we now, in the next period, over the next couple of months, we will show that the total cost of the treatment of fly ash, including scrubber liquid, will be reduced by about 20%. Also, the chemicals consumption will be reduced by 80%. Next slide, please. The full scale will start in October next week. Test period 1, where we will use the treated fly ash, show that we can use it as a construction material, or we will also look into the possibility of using an additive in concrete or cement. That'll be tested and evaluated during this test period. Test period 2 is what we call high salt. We will show that the salt product can be recycled as a brine with about 10% salt content, so no evaporation here. It will be evaluated during this test period if up to 2,000 tons of salt can be used as road salt during the winter period. Test period 3, zinc optimization. The metal product will be upgraded to about or at least 45% zinc, and the zinc yield will be optimized during this period. Finally, the test period 4, the treatment of fly ash from other external waste-to-energy plant, for example, ARC, which is the AMA waste-to-energy plant, you know, the one with the ski slope on it, will be tested during this test period. Next slide, please. Yeah, that's it. Thank you for your attention, and I apologize for the inconvenience with the technology. Thank you.
Thank you, Erik. I think even if we had some difficulties with the technology, there are some questions. I think we will at least ask 1 or 2.
Yeah.
So there is a question that you partly answered, and that was which are the metals obtained in the metal phase, and are those, do they have an economic value if you don't separate them?
The main metal in the metal product is of course zinc, as shown. And in order to get metallic zinc out of it, you have to remove the cadmium and the lead inside in the product. It has for the time being, it has a low positive value, the metal product as is.
Yeah. There's a question, where do you the mercury from the fly ash go?
Well, I didn't really tell you about this, but the mercury, we have planned that the mercury removal from the scrubber liquids will be installed later on. And the rest of the mercury will be distributed between the metal product and the treated fly ash.
Yeah. How high is the remaining chlorine content in the metal product?
In the metal product, it is, we plan to go between 0.1 and 0.5%.
And then I think a last question, since we should move on to the next speaker. How robust is this technology considering the changing qualities of the fly ash from waste to energy?
The plant has been designed in order to take care of changes in composition of the scrubber liquids and the fly ash, both short time and long term changes.
Okay. Yeah, we can take this last one. When will your test program be completed? If everything goes according to plan.
About 12 months from now.
Yep. So in a year.
Yeah.
Yep.